And I share the same birthday.
Nice.
So, like, that just makes her even more special.
All right. Let's take a look at these. So there was one similar to this on homework 2. And what we're going to do is we're going to see which of these are equivalent. So what we're going to do is we're going to look at these statements down below, and we're going to kind of use our condensing rules to see if we can simplify it a little bit. Thank you. Do you think I forgot to do attendance? But that's fair. I'll take that. So if we were to condense these logs together, what happens when we have a subtraction between? We divide. So if we were to condense this one down, we'd have our log with that base of 1/2, which is fine. And we'd have 12 divided by 3. What is 12 divided by 3? 4. So this becomes log base 1/2 of 4. Does that match what we're looking for?
Mm-hmm.
So that one matches. Oh yeah, there's more than one. What if we did with the plus? What does the plus turn into when we condense it down? Multiplication. So this would be our log base 1/2 of 2 times 2. 2 times 2 gives us 4. So log base 1/2 of 4. So this one is the same. What do we get for C when we condense that down? Yeah, because we have, again, a plus right here, so that means we're going to take our 3 times 1. That one does not equal 4, because this is log base 1/2 of 3. So that's not one of them. What about D or E? What do we think about those two? There we go.
E, yes, D.
Why?
Because the -2
Mm-hmm.
it means that it's a power of -2, and that makes it makes it a fraction.
Mm-hmm.
And then the positive of it though makes it lower.
Yep.
Words
Yep.
are not wording.
Your words are wording just fine. All right. So we got that the first one has a power of -2. That would make that be log base 1/2 of 1/4. And the bottom one, since we have a not negative exponent, we just get our 2 squared, so that does equal 4. So this is another one that's equivalent. Our last two are just numbers, so that means we're trying to figure this one out. So that's when we're thinking about if we switched it out of log form back to its exponential form. Log is b of a equals p. What would the power be? Mm-hmm. Yeah, because our base is 1/2. So what this is telling us here, I'm going to bring this over here, is our base of 1/2 to some power needs to equal 4. And in order to get it to flip, we need it to be negative. And in order for the 2 to turn to a 4, we need it to be squared. So 1/2 to the -2 gives us that positive 4. So our options on here were A, B, E, and F. Okay. Questions on that one? And then we've got one more on the bell up here. We're going to do this solving one on the right. Oops. Okay. How do we go about solving something like this? Over here. Finding a common base. What common base can we have there? How could I rewrite that?
In parentheses, you could put 2 squared and then half the
Yeah.
x minus 1 on the outside.
Because I can rewrite this as 2 to the 3x equals, and turn that 4 into our 2 squared to the x minus 1. What do I do with my 2 and my x minus 1 to get the parentheses to go away? It's multiplying them together. Because if I do that, we're going to have our 2 to the 3x equals 2 to the 2x minus 2. But now I don't have any parentheses, and we can go, hey, wait a second, those bases are the same, so I can ignore them. I just need to know when these exponents equal each other, when these powers are the same. When does 3x equal 2x minus 2? What do we do?
Subtract 2.
And we get? X equals -2. And if you wanted to, you could always come in and check this and say, well, 2 to the power of 3 times -2, well, 2 to the -6. 4 to the power of -2 minus 1, 4 to the -3rd, 2 to the -6, and 4 to the -3rd are the exact same thing. That'd be 1/64, I think. So we're using our knowledge of the exponential stuff to be able to solve these things. This is actually leading us into what we're going to talk about today. Because we're going to start solving some logs. And it's going to start out surprisingly similar to this stuff. Okay? So we are going to be in your notes packet. We are going to be on page 8. So, looks like this. Actually, it doesn't look like this. There's not a lot of space. It says lesson 8.3 extra note solving basic logarithm equations. That says common logarithm and natural logarithm. That's the top line up here. And then I've given us some options because I know a lot of us like to have like lists or choices like that straight up spelled out for us. These are our options straight up spelled out for us. There's a little bit of space between where it says common log, natural log, and the first problem. That would be a fine place to put these other pieces of information. So on the common logarithm blank where it's asking us to remember that, it's reminding us that the common log, that's what we call our log base 10 of whatever our argument is. And we typically write it just as log of that argument. You don't have to put the base on for our common log. And that our natural logarithm, that is our log base E, and we typically write that as ln. Oh, sorry, log base E of some argument is ln of that argument. And then when we're looking to solve things, there's a couple of different kinds of problems we're going to see. We're going to see with logs on both sides. And we're going to see when they have only one log. So when there's logs on both sides, and when the bases are the same, which we should at this point only see bases be the same. I will tell you when we're going to not. What we're going to do is very much like how we did it in the bell work, where once our bases were the same, we only looked at the exponents. Well, now with logs, when our bases are the same, we're only going to look at the arguments, because that other part matches. And if we have only one log, if there's logs on only one side, what we're going to do then is switch it into exponential form. BPA log BAP. Those guys. One thing that's super duper duper important with logs. We have to check our answer. We don't have to go all the way in through like solving it to like make sure it's right. What we need to make sure is that we do not have any negative bases. We shouldn't be changing our base right now anyway. And we cannot have any negative arguments. No negative bases, no negative arguments. Negative powers are okay, but no negative bases, no negative arguments.
Are we ever going to get negative bases or negative arguments?
We will run into negative arguments. We should never run into negative bases. Just if we see that, no, that's bad. It no longer functions properly. But we will run into negative arguments, and that's where we're going to get our extraneous solutions. They make us do all that work, and it's not even a right answer. Oh my God, it's so extra. Oh my God. They're extraneous. It's so extra. Oh my God. Okay, so we're going to look at these. We've got a few of them on this page. We're going to get through as many as we can. So here's our first one. We're going to solve. We're going to check. So here we have, for number 1, log base 15 of minus 2v equals log base 15 of 3v plus 1. So that means we want to solve this. I want to know what v equals. Solve means get to a letter equals. And what we have here is we have 2 logs that have the same base. Those 2 pieces are equivalent. So it's kind of like having 15 to the something and 15 to the something. Those 2 powers would need to be the exact same. So those 2 arguments would need to be the exact same. So what we can do when the base is the same on both sides is I can just take my 2 arguments and set them equal. Minus 2v and 3v plus 1. I want to know when minus 2v equals 3v plus 1. I have to fix this circle because that's going to bug me. There we go. So how can I solve this bit? Say it a little louder. Subtract the 3 or add the 2. Either way is fine. We want to get those v's together. I'm going to go with subtracting the 3 just because then I don't have to do as many moves. But if you want to add the 2 and then subtract the 1, that's totally valid. So we're subtracting the 3 from both sides because that makes those 2 pieces cancel out. We're going to have minus 5v equals 1. I want a little bit 1 here. So how do we get the v by itself? We're going to divide by negative 5. So we get, for our answer here, v equals negative 1/5. This is the solution we get. That's a solution. We do not know if it is valid yet or not, but that is our solution. Question on that bit? Because then we need to check. And what we're checking is we're checking to make sure we do not have any negative arguments if this is our letter. So we're going to look at each of our arguments, that minus 2v, and say, well, if that v is our negative 1/5, is this going to be positive or is this going to be negative?
Positive.
Because I have a negative 2 times a negative 1/5. This is going to be positive. We don't really care what the value is. If you want to get all the way to the fact that it's going to be 2/5, totally valid. But all I care about is it positive? It needs to be not negative, and that's what we care about. So that one's going to be positive, so it checks. We got to do the same with our other argument, with the 3v plus 1. So we're going to look at it as our 3 times that minus 1/5. That was supposed to be green, but whatevs. Same vibe. Plus 1. Is that going to be positive or negative? And if we need to, you can type it in the calculator. Yeah, it's going to be positive because the 3 times the minus 1/5, that's going to be negative, but it's going to be small. Plus the 1, we're going to have a positive 2/5. So this one also checks. Both arguments need to be positive for this to be valid. So this is a valid argument. or a valid solution. So when the bases are the same, when the log bases are the same, I just set them equal. I'm going to try another one like it. The questions on this one? Mm-hmm.
So, regardless of the question, it has to, both of the checks have to be positive.
Any of the arguments have to be positive. So any of these guys that are after the log. I was going to say, because there's going to be times when we can have like negative powers. So like when we look at something like number 3, like I could have a negative power over here. I just can't have a negative argument. We'll look at 3 in a minute. We're going to do number 2 first, but so things like that. In fact, I don't know that we're going to see any today, but we'll do it tomorrow. All right, so number 2 is very, very similar. I've got log base 4 of 3x plus 7 and log base 4 of 7x minus 3. So I see that we have that same base on both sides. So that means just like with exponentials, I can ignore it. If the base is the same, I don't need to keep it. We can just look at our 3x plus 7, and we want to know when that equals our 7x minus 3. It should be on page 8. Page 8. It's this one. You know, are we surprised at all that on my copy I also use lots of colors? Page 8. To be fair, I do that on all of them. All of my notes are very colorful. All right. What do we do here? What's going to be our first step?
What I did was I subtracted 7x
Absolutely valid.
on both sides, and I also subtracted 7
Mhm.
on both sides.
Yeah, those are both absolutely valid moves. Not your only option, but absolutely valid. If you wanted to have the least amount of negatives, you move the smallest of the x's, but it really doesn't matter. So if we do it in this order, we get 3x minus 7x giving us negative 4x. And because this piece and that piece cancels out, and this piece and that piece cancels out, and we get minus 3 minus 7 giving us negative 10. Because they're the same on both sides, it's just like if we had this as, I think 4 to the 3x plus 7 equals 4 to the 7x minus 3. So if we had those bases, just like this, since that's what this log base 4 is, it's essentially the inverse of an exponential. So the bases are the same, just like we did in the bell work. Once our bases were the same, we could get rid of the bases here. It's the same vibe with logs. Since the bases on these two guys were the same, they're irrelevant. I can just look at the arguments. Good question, dear. I'm always good with that so we don't get confused by it. What do we get as our value for x?
5 halves
Mhm.
or 2.5.
Yeah. So we divide both sides by that negative 4. We get negative 10 over negative 4. But that simplifies. That fraction, both of those pieces are divisible by 2, and they're both negative. So when we simplify it, we get 5 over 2. Or if you are a genuine fraction hater, you can absolutely do the 2.5 as a decimal. That's totally fine. Genuinely doesn't matter. They mean the same thing. So then what we need to do is we need to go through and check and make sure that we don't get any negative arguments before we can say for sure that this is a valid solution. So this is what we get when we solve it, but we need to check. So both of these little arguments in here, we're going to take our 3x plus 7 and substitute in our 2.5. Is this going to be positive or negative when we work it all the way out? Is there a negative in this statement anywhere? Is this going to be positive or negative? Positive. There is no chance for this to be negative because there's not a minus sign in the whole system. So this is positive, so it's going to be just fine. What about for our other argument? We've got our 7x minus 3. 7 times our 2.5 minus 3. What do we think? Is that going to be positive or is that going to be negative? Positive. Because 7 is bigger than 3. Multiplying it by 2.5 is only going to make it bigger. So that's definitely going to be positive. So it doesn't matter what that value is. It just needs to be a positive argument. And you can just check it like this. You can get all the way to a number and tell us what those arguments are. But doing it this way is totally fine. So that means that this is a valid solution. Yes, both of them will be positive. So it is valid. We have checked it. You don't have to write out the word valid. You can put a check mark if you want to. Like, that counts as checking it. Okay. So when there's logs on both sides, we're really just looking at our argument. Let's see what we do when they only give us one log. So let's look at number 3. When we only have one log, we are going to use the fact that our BPA is the same thing as log base B of A equals P. We're going to be using this information. The log has to be structured like this. It can't have other things around in front going on. It has to be log base B of a thing all by itself. So for 3, what's the base on our log? What should be here? If there's no base, 10. That's our common log. This has a base of 10. So if there's no base there, and it's written as log, it's a base of 10. So we have here log base B of our argument equals the power. So switching this into exponential form, we get our base of 10 to our power of 3 equals that argument of 5x minus 3. We're switching it to exponential form. I have to put EXP form. Because it only has one log. What is 10 to the third?
Let me make sure.
1,000.
I just realized you just add the number of zeros.
It's that number of zeros. Yep. It is. What can I do to figure out what x is?
Plus 3.
Plus 3. So now we have that 1,003 equals 5x. What does x equal? How do we get to x by itself? Divide both sides by 5. And we can use our calculators because it'll simplify for us. I don't know that it does simplify now.
It doesn't, but
But if you switch it to a decimal, we can do that.
yeah, decimals way more pretty.
Our decimal should be 200.6. But you can leave it as a fraction. It's just 1,003 over 5 if you really like it. More power to you. But 200.6, 200.6, I'm good at words. 200.6 is our x. We still need to check it. We need to make sure that we have a valid argument. So we're going to check it. So if I substitute in my 200.6 here, are we going to have a positive argument or a negative argument? As I say, if we substitute it in right here, 5 times 200 is definitely bigger than 3, so this is going to be positive. Like, that's totally fine. So we checked it. Ta-da. What's that?
It's a highlighter.
It is. I'm just running with it.
Check marks always look really weird. I don't like it.
That's okay. I don't judge the prettiness of your check marks. All right, the next one, we have a couple of options. You're going to get to the same answer easy either way. One of them is easier than the other. What's our instinct with number 4? What do we notice?
Oh, there's a 9.
There's a 9 in the front. What can we do with that 9?
No idea. That power spot.
I was going to say, we could use our condensing rules. I could take this up and put it as a power. Unfortunately, that is the hard way.
Oh.
Because then we'd have 5r to the 9th. And we would have to wind up doing a 9th root of something. Ew, gross. So this is one of the benefits of our condensing rules and things. Is because we had a power up here, or we could have a power up here of a 9. But now that we're doing it here, and it's down in the regular set of numbers, what if I just had 9x equals 36? What would we do to get rid of that 9 in front now?
Divide by 9.
Divide by 9. That doesn't change what we can do over here. I can still divide this side by 9. I can still divide this side by 9. And they still cancel out. So we can use the condensing rules. That's totally fine. And there's going to be times when it does help. But this is not one of them. So we can divide both sides by 9. That's going to give us log base 2 of 5r equals 36 divided by 9?
4.
4. So now we have our log by itself, and we can get ready to solve this. We couldn't switch this into exponential form up here without getting rid of the 9, because notice in our log to exponential form, there is nothing in front of the log. We do not have options for out here what to do with anything out front. So it has to be a log by itself. So switching this to exponential form, we're going to have our base of 2, our power of 4 equals our argument 5r. So we switch it back to its exponential form, and that gives us something we can work with. Because what is 2 to the 4th? 16. So we have 16 equals 5r. So what does our r equal?
3.2.
Yes, 16 fifths or 3.2. I genuinely do not care if you put it as decimals or fractions. It genuinely does not matter to me. If we substitute in that 3.2 for r up here, are we going to have a valid answer, or is it going to be wrong? It's going to be positive, so it also checks. As long as our arguments are positive and our bases are positive, but again, our bases should not be changing right now. I'm just continuing to reinforce that, because at some point we will change our bases, and so
Why are check marks unnecessarily hard to do?
because you're overthinking it.
I always overthink.
Shock. Okay, we're going to look at 5 and 6 on this page as well. And that'll be it. So 5 and 6. So we've got 5 times log base 5 of a plus 8 equals 15. Do what? Divide by 5 on both sides. Absolutely right. We want to get our log all by itself first. So we're going to divide by 5. That's going to give us our log base 5 of that a plus 8 equals 3. Then what? How do we set it up? 5 to the what power? Third equals that a plus 8. What is 5 to the third?
125.
125. So we have 125 equals a plus 8. How do we get a by itself? Subtract 8. Minus 8 from both sides. 125 minus 8. What do we get for a? 117. If we have 117 as a value, is our argument valid or is it negative? It's valid. It's just important that we check because we will get to the point where we see it eventually. Just we're starting out by being nice and not giving you icky ones right off the bat. But it's important that we're in the habit of checking. All right, one little extra step on this one. What do we need to do first? We can't do 7 minus 3 here because that's 3 times this guy over here. So we can't do subtraction before we would do multiplication. So order of operations says we can't subtract the 3 from the 7. But what can we do?
Divide 7 minus 3.
Only if the 7 had a log could we do the subtraction turning into division.
I tried.
You did. So when in doubt, say, all right, what if this was not a log? What if this just said 7 minus 3x equals 6? What would we do for this one?
Minus 7.
We would minus 7 from both sides. I want to get the log by itself. So we're going to minus 7 from both sides. When in doubt, if you cover up the log, sometimes you can like cover it up with your finger and make it not look like a log because it scares us sometimes. But we need to get the log by itself so that we can switch it back to exponential form. So I need to get this guy all by himself. Yes, dear. Because this is actually 3 times the log base 8, and order of operations says I can't do my subtraction before I do my multiplication. But I can make my addition and subtraction leave to the other side where we have our minus 3 log base 8 of x equals 6 minus 7 gives us a negative 1. Then what can we do? Divide by negative 3. If you're really feeling froggy, you could put it up into powers, cube roots we can do, but like you don't have to, so I'd rather not. So we divide both sides by negative 3. We get log base 8 of x equals negative 1 divided by negative 3 is 1/3. And then we switch it back to exponential form, where our base is 8. Our power is 1/3. And it's going to equal our argument of x. So we need to find 8 to the 1/3. What is 8 to the 1/3? You can do that in the calculator. It'll let you. Yeah, because what our fraction exponents are telling us is this is asking us for the cube root of 8, which is 2. So this is pulling up that old fractional index thing. It's been a minute. Last step on the very last problem for today. If x is 2, is our argument positive? Yep. because 2 is a positive number and our argument is 2. So it checks. It's valid. Our argument has to be positive and our base has to be positive. Those are the important pieces on there. Okay? We will work more with our solving stuff later this week. We'll hit some of them on Thursday because tomorrow we have our skills check. The solving will not be on the skills check. It'll be just the 2 previous sections where we had our condensing, our expanding, maybe a little bit of the graphing stuff, that kind of stuff. But we're going to do the skills check tomorrow. And then I'll get after the skills check, I'll give you guys the 8-3 homework. It's not due until after spring break, so I'll give it to you guys tomorrow after the skills check. Okay? I mean, unless you want it now. I've got it, but kind of figured you did. Alrighty? Oh, you have no idea the vast variety of pun memes I have.
Yeah, you showed me that one time.
For a vast variety of topics. And it only grows. And I keep my meme folders very relevant. It's divided usually by chapter.